Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 16 from chapter number 2, Vectors and Equilibrium. In the previous lecture we have discussed about how to multiply a vector with a vector to get a scalar, or we have discussed about scalar or dot product. We have defined the scalar product as the product of two vectors. Let's say if it is a vector A and vector B, then what we have to do, we have to join those two vectors with their tails. We have defined them as, if we are going to multiply two vectors, then how we are going to get the answer. When two vectors are multiplied, we can obtain two types of results depending upon the physical nature of the vectors: scalar product or vector product. If we are going to multiply two vectors and the result is a scalar quantity, then we will say it is scalar or dot product. And if we are multiplying two vectors and the result we are getting is a vector, then we will say it is vector or cross product. Keep this in mind that we are just multiplying two vectors, not more than two vectors. Okay, we are just discussing the product of two vectors. This whole discussion is for multiplication of two vectors. We have also discussed about the definition of scalar product and its formula. A dot B is equal to magnitude of A, magnitude of B, and cos of theta, or we can also write it as vector A dot vector B is equal to AB cos of theta. We have discussed about examples. Work is equal to force into displacement, and power is equal to force into velocity. Okay, we have discussed all these things, and we have also discussed about the these things that if we are going to take dot product between two vectors A and B, then first we have to place the vectors tail to tail. We have to connect those vectors from the tail. Then we have discussed this thing that if we are dropping the projection of vector B on A, we will get the result magnitude of A multiplied by component of B along the vector A, or we can also drop the projection of vector B on vector A, and then we will take the magnitude of vector B multiplied by a component of vector A along the direction of B. Okay, we have discussed this thing, and we have also discussed about the angle, that if angle is between 0 and 90 degrees, then what will happen? The dot product will be positive because cos theta will be positive. If angle is between 90 and 180 degrees, then dot product is negative, and if the angle is 90 degrees exactly, then dot product will be 0. We have discussed all these things in the previous lecture. This lecture is the continuation of dot product or scalar product. Okay, so in this lecture we will discuss about characteristics of dot or scalar product, commutative property of dot product of unit vectors, and some basic applications of dot product. We will discuss all these things in this lecture. Okay, so we have discussed that we can define dot product as the product of magnitude of one vector to the component of second vector in the direction of first vector. That vector A dot vector B is equal to A multiplied by component of B along A, or projection of B on A, whatever you are giving the name. This B cos theta, we will say that it is the product of magnitude of one vector with the component of second vector in the direction of first vector. Okay, we have dropped the perpendicular from vector B on the vector A, and we have multiplied this magnitude of vector A with the magnitude of horizontal component of B. All these two were giving us the dot product of vector A and vector B. Okay, and we have also discussed this thing that we can either draw projection of B on A, which we have already discussed, or we can draw projection of A on B. Okay, B dot A and A dot B. Okay, we will get the same result. A dot B is equal to magnitude of A multiplied by component of B along A, that will give us AB cos theta. And if we are finding out B dot A, then we can write it as magnitude of B multiplied by component of A along B, that is again AB cos of theta. Okay, so if we are dropping perpendicular from A on B, then again we will get the same result. So what we can say? We can say that if we are talking about scalar product, A dot B is equal to AB cos theta and B dot A is equal to AB cos theta. From equation 1 and 2, we can say that A dot B is equal to B dot A. Okay, so scalar product obeys commutative law. This is commutative law basically. So scalar product is obeying commutative law. If we are changing the order of the multiplication, if we are placing A vector first and then B vector, then it will make no change. A dot B is equal to B dot A. So scalar product obeys commutative law. We will say that A dot B is equal to B dot A. Okay, keep this in mind that for scalar product commutative law holds. Okay, then we can say that if we are having two vectors and the angle between those two vectors is 90 degrees. If theta is equal to 90 degrees, we are having normal vectors, orthogonal vectors, perpendicular vectors, then the dot product is 0. How we are going to check this out? Let's say that we are having two vectors A and B and we are taking dot product between those two vectors A dot B, which is equal to AB cos theta. Okay, and we have already discussed this thing that these two are orthogonal or normal vectors, so we will put theta is equal to 90 degrees. We will put theta is equal to 90 degrees. Okay, so in the next step, as we know that cos 90 degrees is equal to 0, so we will put value of cos of 90 degrees AB into 0, that will give us 0. So what we have concluded that dot product for perpendicular vectors is 0. Okay, so if we are having two vectors A and B, those are perpendicular to each other, then their dot product is 0. We have also discussed this thing that dot product is basically the measure of parallelism of two vectors. It is telling us that how parallel two vectors are. So if two vectors are perpendicular, their dot product must be 0. Okay, and if we are having two vectors which are parallel to each other, if theta is equal to 0 degrees, parallel vectors are there, then the dot product is maximum. Okay, how? If we are again putting in the formula A dot B, vector A dot vector B is equal to AB cos theta, which is equal to AB cos of 0 degrees, because we are having parallel vectors, so theta will be 0. As we know that cos of 0 is 1, so we will put its value AB into 1, that will give us AB, maximum product. Okay, complete magnitude of A multiplied by magnitude of B. So if two vectors are parallel, then dot product is maximum. Okay, now we are having two vectors which are parallel to each other. Okay, so what will happen? The dot product will give us maximum value, magnitude of A multiplied by magnitude of B. Okay, now if we are having two vectors which are anti-parallel to each other, okay, if theta is 180 degrees, anti-parallel vectors, then the dot product is minimum. Again we will follow the same steps. We will put the formula A dot B is equal to AB cos theta. We will put the value of theta, which is 180 degrees, AB cos of 180 degrees. We know that 180 cos of 180 degrees is equal to -1, so AB into -1, we will get negative magnitude of A multiplied by magnitude of B. So we will say that if we are having two vectors which are anti-parallel to each other, then they will have minimum product. Okay, one more thing, that if we are talking about practically theta should be between 0 and 90 degrees. It should not be more than 90 degrees. Okay, but theoretically we are considering this thing that if two vectors are anti-parallel, then what is the dot product? Okay, because you know that magnitude should not be negative. Okay, so practically it should be between 0 and 90 degrees, but we discuss it between 0 and 180 degrees. So you have to put this thing over here, that if theta is 180 degrees, two vectors are anti-parallel, then the dot product is minimum. Okay, so if we consider another case in which we are having dot product is equal to 0 and theta is not equal to 90 degrees. In the previous lecture we have discussed this thing, that if dot product is 0, it means that two vectors must be orthogonal. But what if condition is given that dot product is 0 and those two vectors are not perpendicular to each other? Then what does it mean? It means that if dot product between two vectors is 0 and theta is not equal to 90 degrees, then either vector A is 0 or vector B is 0. Okay, one of the two vectors must be a null vector. If dot product is 0 and these two are not orthogonal, not perpendicular to each other, then either vector A is 0 or vector B is 0. Okay, these two conditions must be fulfilled. Okay, either A is 0 or B is 0 or null vector. Okay, either say it as 0 vector or null vector. So what we will say, if dot product is 0 and two vectors are not perpendicular, then either of them should be a null vector. Okay, consider another case. If we are having a vector and we take dot product of a vector with itself, we are multiplying a vector with itself, we are taking dot product of a vector with itself, then what will be the result? Okay, we are having two vectors which are placed one on another. Okay, so what we will do, you can check it out again. We will put in the formula A dot A, because we are taking the self product of a vector with itself. Vector A dot vector A is equal to AA cos of theta. So if vectors are same, then they are along the same direction, angle between them must be 0, so we can write it as A square cos of 0 degrees. Okay, that is equal to A square into 1, cos of 0 is 1, that is equal to A square. So we can say that if we are taking dot product of a vector with itself, then we will get square of its magnitude. All these things are not discussed in your book, but you should know all these things. Okay, these are important from MCQ's point of view or conceptual questions point of view. You should know all these things, you have to note it down. Okay, so if we are taking dot product of a vector with itself, then we will get square of its magnitude. Okay, and if we are talking about dot product of unit vectors, if you remember this thing, that we are having unit vectors I hat, j hat and k hat. I hat is the unit vector along x-axis, j hat is the unit vector along y-axis, and k hat is the unit vector along z-axis. Unit vector having magnitude 1 and it is along that specified direction. Its magnitude is 1 and direction is along the given axis. I hat for x-axis, j hat for y-axis and k hat for z-axis. Okay, so if we are taking dot product of unit vectors, then what will happen? If we take dot product of similar unit vectors I hat and I hat, for example, how we are going to do that? I hat dot I hat. We know that formula for dot product is A dot B is equal to magnitude of A into magnitude of B with cos of angle between the two. Okay, so we are taking dot product between I hat and I hat, magnitude of I hat and cos of angle between the two vectors. Obviously these two are same vectors, so angle will be 0 degrees and magnitude of unit vector is 1. Okay, because it is unit vector, so its magnitude will be 1. So we will put all these values, magnitude of unit vector 1, 1 and cos of 0 degrees. So we will get cos of 0 degrees, and we know this thing that cos of 0 degrees is again 1. So we will say that I hat dot I hat is equal to 1. Answer of I hat dot I hat is equal to 1. If we are taking dot product between j hat and j hat, okay, then what will happen? We will follow the same steps. J hat dot j hat is equal to magnitude of j into magnitude of j, cos of angle between the two. Again, magnitude of j hat is 1 and angle is 0 degrees. So cos of 0 degrees will be there. J hat dot j hat will be equal to 1. Okay, so the dot product of similar unit vectors is equal to 1 because they are along the same direction and their magnitude is 1. Similarly, if we are going to find out the dot product between k hat and k hat, then what we will do? K hat dot k hat is equal to k hat magnitude of k hat into magnitude of k hat, cos of angle between the two. Okay, k hat along z direction. So again, 1 1 cos of 0 degrees, that will give us k hat dot k hat is equal to 1. So we have proved this thing, that if we are finding dot product between two similar unit vectors, then it will give us 1 because angle between these unit vectors is 0 degrees. Okay, then if you are finding dot product between similar unit vectors, that will give us 1. You can write it as I hat dot I hat is equal to j hat dot j hat is equal to k hat dot k hat, which is equal to 1. Okay, you should learn this thing, that dot product between similar vectors, similar unit vectors is equal to 1. Okay, so now what if we are going to find out the dot product of different unit vectors? For example, I hat and j hat. If you are going to find out the dot product of I hat and j hat, then what will be the result? Check this out. If we are having I hat dot j hat, then what will happen? We will have magnitude of I hat multiplied by magnitude of j hat into cos of theta between them. I hat dot j hat is equal to magnitude of I, magnitude of j hat, and cos of angle between the two. You can see that the angle between I hat and j hat is 90 degrees because x-axis and y-axis are having angle of 90 degrees between them. So we have to put these values over here. Magnitude of I hat and j hat, again 1 1 and cos of 90 degrees. We know that cos of 90 degrees is 0. So I hat dot j hat is equal to 0. Similar is the case with the dot product of perpendicular vectors. If you remember that thing, that dot product between perpendicular vectors was 0 because cos of 90 is 0. Same is the case with unit vectors. Okay, again finding out the dot product between k hat and j hat, we will write it as k hat dot j hat is equal to magnitude of k into magnitude of j into cos of angle between 2. Putting the values, magnitude of unit vector is always 1. Okay, it can never change because it is unit vector, so its magnitude is always 1. Cos of angle between k hat and j hat, that is between y-axis and z-axis, that is 90 degrees. So cos of 90 degrees is 0. So k hat dot j hat is equal to 0. Again, if we are going to find out the dot product between different vectors, any different unit vectors, then it will always be 0. Okay, so you can say I hat dot j hat is equal to j hat dot k hat is equal to k hat dot I hat. All will give you 0 result because angle between them will be 0. As we have already discussed about commutative property, so if we are changing the order, if we are writing it as j dot I, k dot j and I dot k, again it will give us the same result. Okay, j hat dot I hat is equal to k hat dot j hat is equal to I hat dot k hat. All these will give us a 0 result because all of these unit vectors are having an angle of 90 degrees between them. Okay, so dot product of different unit vectors is always 0. Okay, so if we are talking about associative law for dot product, then if we check associative law for unit vectors, let's say for example we are putting unit vectors because we know the magnitude of unit vectors, then if I hat dot j hat dot k hat, let's say if we are taking left hand side, I hat dot j hat dot k hat, we will check it out, answer of left hand side, then we will move to right hand side. Okay, so we have discussed this thing that I hat dot j hat will give us 0, okay, a scalar 0 dot k hat. Now we are having such a value 0 dot k hat. Okay, what about the result? Should it be 0 because we are multiplying k hat with 0? No, it will not, because 0 over here is not a null vector. This is a scalar 0. Okay, this is simply a number 0, and by definition of scalar product we have to take dot product between two vectors, not between a scalar and a vector. So we cannot find out the dot product between a scalar and a vector. So we will say that associative law is not possible. Okay, dot product is between two vectors, but now it is a scalar dot vector form, okay, which is not possible. So associative law is not possible for dot product. Okay, you will not say that it does not hold. Does not hold means that left hand side is not equal to right hand side. We cannot calculate associative law. Okay, it is not possible because we are getting this form, scalar dot vector. Okay, so applications of dot product, we are not going further in detail. We will just discuss about those applications which we have already discussed, that we can check how parallel two vectors are. We can check by using the dot product that how parallel two vectors are from the magnitude, from the result. Okay, so we can find out work done by the force in displacing a body by using the dot product, and all other examples which are related to dot product, all those are applications of dot product. Okay, and we can find out angle between two given vectors, like if we are having formula a vector dot b vector is equal to ab cos of theta, we can separate out theta. If we know the dot product, if we know the magnitude of two vectors, then we can separate out theta from the formula and we can find out the angles. We are having several practical applications of dot product which are beyond the scope of your book, which we will not discuss here. Okay, so now if we are going to find out a dot b, general formula for a dot b. Okay, let's have two vectors. Vector a is equal to, we can write a general vector, position vector in this form, x component into I hat plus j component, y component into j hat plus z component into k hat. This is the general notation for writing a vector. Okay, this ax could be any value, ay could be any value, and az could be any given value. Okay, like if it could be 2i hat plus 3j hat minus 4k hat, whatever the value it is, it doesn't matter. We are just writing the general representation of a vector. So let's, vector a is equal to axi hat plus ayj hat plus az k hat, and we are having another vector b which is equal to bxi hat plus byj hat plus bz k hat. Find a dot b. You have to find out dot product between these two vectors. How you are going to do that? I will just give you the steps and the answer, and you have to find it out. You have to do it in proper steps. Okay, then you will understand that how we are going to find out the dot product between any two vectors. Okay, let's check out that which steps we have to follow. Okay, first what we will do, that if we are going to show this thing, this will be our result. We will start with vector a and vector b which are given in the question. Vector a, axi hat plus ayj hat plus az k hat, and b is equal to bxi hat plus byj hat plus bz k hat. Then what you have to do, as we have to take the dot product, then a dot b, we will write it in component form. It is basically also called as component form. We will write value of vector a over here, then dot, and then value of vector b over here. Vector a dot vector b. Then what we will do in the next step, you can do it as we have to multiply this with all three. We have to take dot product of this vector with all three, and we have to take dot product of this vector with all three. So we can write it as axi hat first vector dot whole value of b plus ayj hat dot whole value of vector b plus az k hat dot whole value of vector b. Okay, in the next step you have to do it in proper steps. Okay, you have to take dot product of axi hat dot bxi hat plus axi hat dot byj hat plus axi hat dot bzk hat. Okay, then you will separately take dot product of this vector with all three, and then you will take dot product of this vector with all three. Okay, then what you will get? We have already discussed this thing, that unit vectors I hat dot j hat is 0, I hat dot k hat is 0, j hat dot k hat is 0, and dot product between similar vectors will be 1. So you can simply see this thing, that this I hat with j hat and k hat, these two terms will become 0. Okay, dot product of this term with this and this term will become 0. Only these two terms will be left. Okay, dot product of this j hat with I hat and k hat will become 0. Only this central term will be left. Okay, rest of two terms will become 0. And dot product of this k hat with I hat and j hat will become 0. Only this term will be left. Okay, when you will do it step by step, put all these values and then you will find out this answer. A dot b is equal to axi hat dot bxi hat plus axj hat dot byj hat plus azk hat dot bzk hat. Okay, so I hat dot I hat 1, j hat dot j hat 1, k hat dot k hat will be 1. So we are only left with this term ax bx plus ay by plus az bz. So whenever we are having any two vectors, any two general vectors, okay, then we simply have to find out their result by multiplying their x components plus multiplying their y components plus multiplying their z components. So we will get the result of those two dot products. Okay, those two vectors. Okay, you have to practice it as well. Okay, so in this lecture we have discussed about some characteristics of dot product. Let's take an overview of these. What we have discussed this thing, that scalar product obeys commutative law. These are known as characteristics of dot products. Okay, scalar product obeys commutative law. A dot b is equal to b dot a. Then we have discussed that if theta is 90 degrees, normal vectors are there, then dot product is 0. Then we have discussed this thing, that if theta is 0, if we are having parallel vectors, then dot product is maximum. If we are having theta is equal to 180 degrees, anti-parallel vectors are there, then dot product is minimum. If a dot b is 0 and theta is not 90 degrees, then either vector a is 0 or vector b is 0. And we have discussed this thing, that if we take dot product of a vector with itself, then we get square of its magnitude. Then we have discussed this thing, that if we are having unit vectors, then I hat dot I hat, similar unit vectors are having result of 1 if we take dot product between them. Okay, and if we are having different unit vectors, then their dot product will give us the result 0. Okay, now if you are writing this scalar product or this dot product as a long question, then you can make different headings for this. It's up to you that what headings you are making, but a format could be there, that first of all you can write down the definition, then you can draw the figure, then you can write down the equation, examples, physical interpretation, explanation and characteristics of dot product, and then you can write each characteristic with a separate heading. Okay, that will be a long question. Okay, and in physics it is mandatory that you have to draw figures. You have to draw figures whenever required. Without figures you will not get full marks. Okay, so that was all. I would like to end my lecture with this quote, that intelligence is the ability to adapt to change. Okay, so you have to adopt the change, you have to absorb the things in yourself, you should always be ready for the change. That is essential to live in this world. Thank you so much. That was all for today's lecture. Best of luck.